In this work, we define and solve the problem of controllable person image synthesis with attribute-decomposed GAN, a neat and effective generative model. Compared to previous methods to synthesize person image in an arbitrary pose, we can achieve flexible and continuous user control of other important human attributes, such as head, upper clothes, and pants. Another source image with desired attributes can be directly provided. Our method can also bring a significant quality boost for more realistic results. In this task, what we have is merely a typical person image dataset, including RGB images of different persons in several poses. Then, we can get their keypoint-based pose representation with an existing pose detector and segmentation mask with a human parser. We have no annotation of human component attributes for color, shape, or texture pattern. The core idea is to learn an automatic, unsupervised attribute separation in the training. Human attributes are embedded into the latent space as independent codes and combined for the full style code. With the trained model, we can directly provide multiple source persons with desired attributes to construct a new style code. Thus, we can control human attributes via mixing and interpolation operations in the style code. Specifically, we introduce a novel generator architecture consisting of two encoding pathways, and they are connected by style blocks. One pathway for pose encoding, and the other for source appearance encoding, and they are connected by style blocks. In the pose pathway, we use a common encoder consisting of downsampling convolutional layers. In the source pathway, we further extract component layouts using an existing human parser and feed them into a shared global texture encoder for decomposed latent codes. The global texture encoder combines a pre-trained VGG encoder with a learnable one to improve the generalization ability. Texture style transfer aims to inject the texture pattern of source person into the feature of target pose, acting as a connection of two pathways. We adapt two discriminators, dp and dt, to guarantee pose consistency and texture coherence. Our full training loss is comprised of 4 losses. Except for the first 3 common losses, we introduce contextual loss, which is designed to measure the similarity between two non-aligned images. It is also effective in our task. Here are some results of our method. For pose transfer, given a source person image, we can reconstruct it in arbitrary poses. Even the target poses are drastically different from the source in scale, viewpoints, and so on. With continuous action sequences, we can animate the source person with desired motions. Compared with state-of-the-art post-transfer methods, we can produce more realistic results in both global structures and detailed textures. For component attribute transfer, we can edit upper clothes or pants of target images by using additional source images to provide desired attributes. Our model constructs a complex manifold, and you can travel along the manifold from one attribute to another, thus achieving continuous user control. With source A to provide a person image in desired upper clothes, our model can synthesize target images with it transferred. The same goes for head attributes. In this example, everyone will have blonde hair and female face. Except for hair and face, even some headwear like hats can be successfully transferred. Thank you for listening.